Okay, so let's see, an 89,320 kilogram airplane landing at this speed must stop in that distance, right? It's got the engines exerting reverse thrust, and of course the brakes, right? The force of friction is going to also exert a reverse thrust. Okay, so what must be the deceleration, and then what additional force of friction? So this is going to be another one like the Batmobile we just did, only it's going to be, we solve Suvat, right? Okay, then we're going to solve F equals ma, right? And then we're going to solve a coefficient of friction thing. So we're going to use F, force of friction, is mu times m times g, and we're going to know the force of friction, we know the mass, we know g. We'll be able to find that, right? We're going to set up F equals ma, and that'll tell us what the force of friction is, and then we're going to do this, and this will tell us what A is. Okay, so it's very, very complex. This is worthy of your talentedness and giftedness. So our distance is, the airplane is going to stop by going forward positive 415, right? It is going at a positive 83.5 meters per second. It's going to stop, and then our acceleration, I guess I'm going to use what v squared is u squared plus 2as. I love that formula, apparently. Okay, so let's see. So that means A is what? V squared minus U squared over 2S. So A is equal to 0 squared minus 83.5 squared divided by 2 times 15. Okay, so what is that? It is 83.5 squared divided by 2 divided by 415. I'm going to store that thing. That is 8.4003 negative. Okay. Okay, so yeah, we're reassured by this answer, right? Okay, so now let's set up our F equals ma, right? So here is the airplane. Really got to draw a picture of this, right? Airplane, whoops. Sorry, looks like a roller skate. Okay, so let's see. It is decelerating. There actually are two forces. There is the 313 kilonewtons of reverse thrust, right? So negative 313, wow. 1,000 newtons, and that's negative that way. And then, of course, there's also the unknown force of friction, right? That's this guy. Whoa. Okay. And then we're going to find what that is. Now, we don't know that it's negative, but I think we'll find out, right? So let's set this thing up. We're just doing F equals ma, right? So we say, let's see, negative 313,000, right, plus F equals mass, 89,320, right, times the acceleration, which is negative 8.4003, okay? Okay, so I think I get this. It's going to be this times this, and then I'm going to add that to both sides. So this guy I'm getting negative 75,000 roughly, right? Okay, 750,000, sorry. And then I'm going to add 13. And I get that it's the force is equal to negative 437,314.9, in case you cared about that digit way over there that really doesn't mean anything. Newtons, right? So I guess we could say negative 437 kilonewtons, right? Negative 437 newtons, about, right? Okay, so there's that answer. Now we've got to find the force of the coefficient of friction, which looks strangely precise. Okay, so now we just set this up. This is our force of friction, only we don't make it negative. So we say, whoops. Okay, we say 437 314.9 is equal to mu times, I don't have enough space, mu times m, right, which is 89,320, right? Right? Let's continue that, right, times 9.81. Okay, so I'm going to take this number here, right, and divide by this, and divide by this, and I should get mu. Okay, so that guy divided by 89,320, divided by 9.81, and I'm getting that the mu is 0.499087, which I guess with 3 sig figs would still be 0.499. Oh my gosh. Okay, this is a great scandal, okay? Probably it's because I think back in the day we used 9.80 and not 9.81. So anyway, there you go. I hope you enjoyed problem 13.